of our plan, of our mission, this whole establishment is Beyond Einstein. Cree, who is Albert Einstein?
Albert Einstein was a turn of the 19th century physicist who basically changed the world with this theory of general relativity, for better or for worse. He was brilliant. He created his thought experiment back in 1900 when people were writing courses to work every day. He did it without the benefit of all of the information we've learned over the last 100 years. The guy was a superstar and a very powerful public figure who made incredible contributions to physics at the time, which unfortunately we found out is a little bit detrimental, we did not address.
Why do you feel that Einstein's contributions to physics are detrimental?
So Einstein gave us the theory of relativity, which replaced Newtonian physics. It was a better solution than Newton had proposed 50 years earlier. The problem is that it was taken by the physics establishment and blindly followed, and has been for the last 100 years. There are no checks and balances in the industry. So I say it's been detrimental is because it's wrong, it's not been challenged, and we're still adhering to the same theories to guide our researchers that we did 100 years ago, getting null results. So his contribution turned out to be more detrimental than it was beneficial.
Cree, why do you say physics needs a paradigm shift?
Physics is in desperate need of a paradigm shift. And the paradigm shift occurs when a existing theory that's being adhered to fails to work, fails to deliver results. It's happened dozens of times over the last 3,000 years. We had run our course with relativity as the guiding star. We know we've gotten very poor results from all of our research dollars for the last 100 years. And it's time to recognize that we need to, as painful as it is, go through another paradigm shift. We need a new guiding light to give our researchers, let them go in places they've never gone before.
In your opinion, what got us there, was that a paradigm shift that occurred 80, 90, 100 years ago?
Yes, it was a shift from Newtonian physics to Einsteinian physics. It replaced Newtonian physics. It's been built on for the last 120 years, added to, amended. But the core of the theory is maintained relevance for all that period of time, regardless of what we've discovered. So, the paradigm shift is a necessity in the physics world when you've reached sort of the end of the road of the existing paradigm.
And that's great. You said when you've reached the end of the road of an existing paradigm. What needs to occur for the realization, when are we going to wake up and feel like acknowledge we've hit the end of the road?
So there are two stimuli that drive a paradigm shift. One is a discovery that is basically just obsoletes the prior paradigm, and that happened in 1650 when they saw the planets doing weird things. They had a discovery. The other is a better theory comes out that answers all of the scientific observations, but does it better than the prior one. And that's when Newtonian physics transitioned to Einsteinian physics, because Einstein's theory was better. What we need today is a new theory using all that we've learned in the last 100 years to come in and allow the physicists to say, hey, that makes more sense. Let's follow that theory. Let's redirect our research dollars. Let's redirect our education dollars. And it's time for that.
Einstein once said, curiosity has its own reason for existing. Do you agree?
I do. Curiosity is one of the forces that help advance the evolution of the species. It makes us do things that we would not naturally do. We challenge things. Curiosity pushes the envelope for the human condition. And curiosity in physics is an important contributor to the advancement of technology, medical sciences, energy sciences. And so we need to allow people to be curious and allow people to question the powers that be.
Cree, what's your big grudge with fundamental forces?
We know through 3,000 years of terrestrial physics that nothing moves without some type of an energy exchange, a state change of energy, a transfer of energy from one object to another. Yet, we observed something back in 1932 that they couldn't explain. And rather than saying, hey, the core theory we used to describe this might be lacking, they created something called a fundamental force. Stuff just happens because it happens. No explanation. Why does it happen? Get to the point, there's no reason. And that defies what we know about physics. And yet those are buried in the foundations of both quantum and relativity, and those alone should disqualify the existing theories.
Do you support string theory and its value in physics?
String theory is a creative paper writing tool that physicists use to publish. It has no value. It is a baseless science, and it's being looked at as a potential solution because they've run out of options within the existing paradigm. String theory is a waste of time and a waste of intellectual resources. Very creative people, but the particle physics has ended, and they now are looking for something to do, and they have to publish. And so we're stuck with string theory. No, it has no value.
Why are you such a big fan of Sabine Hasselfelder?
Sabine is one of the few people who stand up and talk about the fraudulent behavior of the institution of physics. She was on the inside, and she saw the ugly inside. The incentives we provide our physicists are wrong. The latitude we allow them to have in questioning the authority is wrong, and she's out there talking about it. What she has that other people don't have is a big personality. She is an attractive woman who can communicate extremely well. And so she's calling bullshit on the physics institution. Well, unfortunately, she doesn't have a substitute theory, but hopefully that will come in the near future.
Creed, do you think that the science research being done at CERN is a win or a waste?
I think that it has been a win in demonstrating that particle physics is not the answer to trying to understand the universe. We've spent 60 years and God only knows how many dollars chasing the particle paradigm and have gotten very poor results. Now they write a lot of papers and they print a lot of stuff because they're incented to do that, and they need to do that to keep the gravy train going. But particle physics has run its course. The good news about what CERN did is it showed us that is not the avenue we need to pursue, so we can go do something else.
Does dark matter or dark energy exist?
No. Dark matter and dark energy are the dumbest plugs trying to protect Einstein's gravitational theory. It is unbelievably unbelievable that they would put that into the core model and then spend dollars looking for it. We're spending billions of dollars looking for dark matter. No, Einstein's gravitation theory is incorrect. It's incomplete. And those are just two more plugs to maintain status quo. And both of those things need to be removed.
What would you define as science's biggest cop-out?
In physics, it is the bifurcation of the theory. It's having a theory of the large that is completely independent, unconnected to the theory of the small. And that is a real problem, one that Einstein recognized, because the large things are simply large accumulations of little things, of atoms. So in fourth grade logic, you would think that whatever is happening at the subatomic level should scale cumulatively to reflect what's happening at the large scale. And they are so far apart now, and they are accelerating away from each other. That Einstein recognized as a critical error, and that needs to be corrected. We need to demand a unified theory of physics.
So you said Einstein identified it as a layer that needed correcting?
Yeah, Einstein started the search for a unified theory. He spent the majority of his career trying to come up with a fix that would create a unified theory and reunite the micro with the macro. He failed. Now, it is the holy grail of physics today to come up with a unified theory of physics. But I would contend it cannot happen in the existing paradigm. The existing paradigm got us into this mess. We can't use the existing paradigm to try to get us out of it. So, we need to change things. to mix it up.
Do you think that mathematics is used as a Band-Aid to help define the justification for a search of a unified theory?
Yeah, we have seen dozens of things over the last 120 years that conflict with these existing theories and with the paradigm we're in. And every time we do that, we go to the mathematicians as the last line of defense to the status quo. They calculate how we can make that observation fit in with this theory, and they discover something or they add a variable. Dark energy and dark matter were added to protect Einstein's gravitational theory. Yeah, mathematicians had saved the status quo for 100 years now, starting in 1930 or 1927. Kind of incredible way to think about it. Yeah.
It's not working. Let's get the math.
It's just, it keeps happening. There's so many of them, and the fundamental forces are with a start at 32. The quantum going in there. Quantum, 1927, when relativity failed at the subatomic level, they shoved a mathematical tool, a probability tool, into theory status. And there's a big argument. They literally had a vote in Europe with all the big powers that be in the physics industry. They voted. Einstein voted against it. We can't elevate quantum. We got to figure out how to make this stuff work. And he lost. And now we're stuck with this. They figured they could experiment their way out of it. They'd discover something. They're not going to. They're looking in the wrong places. They're just, they're stuck. And they all want a paradigm shift, but they all want it to be little incremental changes so that their position in the industry doesn't get diminished.
Interesting you say that. My next question. Would the science world be different today had Nikola Tesla been more famous and admired than Einstein? So Nikola Tesla is more popular than Einstein. Do you think we'd be living in a different world right now?
Yeah, yes. The way that paradigm shifts are blessed is it's basically a popularity contest. You gotta be popular with the people who support you inside and outside of the physics industry. If you go back and look at Tesla's work and some of the conclusions he had back in the 1930s, you'll find that they're really, really good. They're far closer to a solvable theory than what we have right now. Unfortunately, he was a little bit of a pain in the ass, and he was not a character like Einstein was, so he was easily ignored, unfortunately. If Einstein had never existed, and we continued to work off of the late 1800s science, we would be in a better place right now than we are. If we didn't have the theory of relativity and the bending of space-time and all of the unusual things that Einstein had to put in mathematically to make relativity work.
Now, this is not a question on my page here, but
Hey, no free-forming.
no, it's not really free-forming. It's adding into that. Knowing some of Einstein's history of starting out as a clerk in the patent office, people were listening to him at first. What was that shift that made people start to take him? Like, what was that?
So there's a guy named Max Planck, who was a popular physicist at the time, who had a theory about the micro world. And when Einstein came out with his theory of relativity, Planck got his hands on it and read it. Planck pulled Einstein out of the patent office and gave him a platform and supported him. And there's a whole community of physicists back then who then rallied around that and elevated relativity. What's interesting is that, when after they got their power based on the paradigm shift had changed, they sort of used that much Einstein as they needed, and they stopped listening to him. They inserted quantum, so it's like they used the guy, elevated him, and then moved on. They pull him out when they want to go do the Manhattan Project, because he's a great personality for the physics industry. It's not an industry with a lot of personalities.
What's so interesting and important about magnets?
So a magnet it's what we talked about earlier, you look at an object and you want to see the cumulative effect of all of its parts. In a magnet, all of the atoms in it are aligned. So the magnet will demonstrate the cumulative power of each of those magnetic fields. And they're incredibly powerful. I mean, all the electricity we use today is harvested off of the magnetic field, electromagnetic fields. The question that is the unifying question to all this is, where does the magnet, where do the atoms get the energy to do all the work that they do? And that is something that was skated over with the fundamental force crap, and never even attempted to answer the question. If you answer that question, you have the platform for unified theory of physics.
It's not being made public of the research or quest to find out where magnets get their power, but magnets are utilized in tremendous ways
in every turbine in the world, and they're amazing things. The amount of energy that comes out of them is amazing. We think of nuclear energy as a power source of electricity. It's not. Nuclear energy just turns a crank, and so the energy is actually gathered off of the magnets themselves, the fields and magnets.
What is your gripe with today's young physicists? Or do you even have a gripe to say this?
I have no gripe with young physicists. I had a massive gripe with the physics institution. They know that what they're indoctrinating the kids into cannot be right. Yet they go ahead and do it, and they don't explain that all of these things that they're teaching the kids are theories. They teach it to kids as if it's factual. And so they conflate a theory into a fact. And once that happens, once it reaches fact status, when we're looking for a solution to a problem that we had today, you don't even consider that a variable. And there are dozens and dozens and dozens of variables on there that our young physicists are assuming are facts. And that's crippling.
Please explain. We talked about this on the golf course. We've talked about it other times that we sat down and met. What is education versus indoctrination?
So education encourages critical thinking, to question the status quo, to question the foundational principles behind any subject. Indoctrination is, these are all right, we want you to repeat after me and memorize all these things. In the physics world today, the kids don't get ahead by questioning the core assumptions, the first principles. That it disappears back into their background. They get ahead by memorizing and regurgitating what their teachers teach them. And if their teachers teach them something is wrong, they've basically been brainwashed unintentionally. And that's what I think is happening today. They're being taught things that cannot possibly be true.
So they are being forcefully indoctrinated into a pattern of incorrect information.
Yes, yeah. And again, it's not intentional. There's no maliciousness in this thing. But if you want to get ahead in physics, you do not get ahead by questioning first principles. You get ahead by repeating what your professors have told you really, really well and understanding it. And once you do that, it's ingrained into your thought process. If you want to do a thought experiment and you think of something as a theory, as a fact, it's no longer a variable, you can't solve the problem. And that's where we are today. We expect our physicists to solve this problem, to unify the theories of physics. But they can't do it because every one of them was indoctrinated into the same paradigm of thinking, and they need to be released from that. Theories need to be tough. You've got to be able to differentiate between theories and facts, and they've merged, and it's really bad.
So when these are taught, they're labeled as theories, not facts, right?
They don't even differentiate though. If you read a book, they will do a disclaimer.
Okay.
But they are treated, there's no room for the student to say, well, why don't we try to improve on that? There's no encouragement to say, let's go look at the idea that the sun is a giant ball of hydrogen isn't questioned anymore. It's a really dumb theory, because if you look at the conflicts it has with all the other theories surrounding the formation of our sun, it's impossible that it's not much hydrogen. But it's told us, it's taught as fact. It's unstandable hydrogen. No. We have a teeny little amount of information that would suggest that the exterior of the sun is hydrogen and helium, but that's it. And then it's, now we dig a little deeper, all of a sudden we're to nuclear fusion, because that's the only way they could explain how the radiation comes out of there. And now we're looking for fusion reactions that are net neutral energy transactions. It's kinetic to nuclear. And, it's just, the air is compound. And that's been happening now for 100 years. And we have to break the cycle.
Interesting in there, as you were answering education versus indoctrination, and use as an example, the sun's a giant ball of hydrogen. How do we know that it is, or how do we know that it is not?
We have very little data. So we have the sun's luminosity. It's 10 to the 26th watts of energy per second. We have a spectral analysis of the sun's exterior, which is hydrogen and helium. And that's it. We don't know anything else. We have no idea what's under the corona of the sun. And they take that information and then they blow it up into all of this different stuff. The body of the sun is just like every other object in our solar system, in the universe. It is made up of a whole bunch of complex materials. And the exterior of the sun, the event at the exterior of the sun is a surface event that is creating luminosity. And in the corrective theory, it's easy to explain. It's just exactly the same thing that happens above the surface of an atom, nuclei of an atom. But if you ask a physics professor, is it a fact? They'll say yes. No, it's a theory. But everybody's taught it as a fact. When I got taught it was a fact. The sun's a giant ball of hydrogen. That doesn't make sense. Why is there so much hydrogen there and so little here? We formed out of the same dust cloud. Anyway, but that's now stamped into from theory into fact mode. And that's dangerous.
What is the God particle?
So there's a guy named Higgs, 40 years ago, came up with a theory that there was a certain type of particle, and that particle, if it existed, could unify large-scale physics with small-scale physics. And they looked for it and looked for it and looked for it and looked for it. It was sort of the goal of the super colliders is to find the God particle, Higgs boson. They found it. They found it. If you read any of the releases, you'll find out there's a disclaimer at the end of it saying, it may or may not be there. They used it to finance an expansion of some of the super colliders as an excuse of, hey, we're really successful, we're kicking ass. It's a big yarn. Nothing came out of it. But it served its purpose. They wrote a bunch of papers on it. They claimed victory, and they got another several $1 billion.
Is there more than one super collider than what exists at CERN?
Yeah, the Chinese have one. I don't know how many there are. There are several. I think CERN is the granddaddy of them all. China's doing one that's gigantic. I think it's a decade away from completion.
I heard this strange conspiracy theory about CERN and the God particle. And it has to do with UFOs. And are you familiar with it?
No.
Well, have you heard that there's increased visibility or presence of sightings of UFOs when we set off nuclear blast?
No. You're not dragging me down.
Can you walk us through a high-level thought experiment?
Let me start with what a thought experiment is. A thought experiment is like a computer program. You put some facts into it, you put some variables into it, and then you use the facts as a baseline, and you manipulate the variables to try to figure out a problem. And it runs around in your head over and over and over again. So a thought experiment is only as good as the assumptions that went into it. It's the garbage in, garbage out idea. If you put things in as if it's fact, but when it's treated as a variable, then you manipulate the variables, you cannot come up with a solution. Because you've got a fact in there that is actually a variable. So thought experiments are limited by the quality of data. Now, Einstein's thought experiment was done back in 1905, the first one. And in 1905, think about it back then. There's no TV, there's no radio, there's no car, there's no airplane. The information he had going in there was void of 120 years of information that we have right now that we could leverage off of. So I don't know if that answers your question, but a thought experiment is extremely limited, but allows an enormous amount of creative flexibility.
That answers it.
And if you don't get it right, you go back and you manipulate the variables again, then try it again, and do it again. It's basically what happened to me over a 30-year period. It happened, late at nighttime, unintentionally. The stuff would just drop on me, and it's like, wow, that's interesting. Well, I do what's wrong. The result is right, I believe.
During your conversation with Larsh, he asked you a question about technology and AI and your opinion on AI being able to assist this new high-level thought experiment, supporting the inconsistencies of Einstein and other physicists.
Yeah, I think that AI has the same limitations that a thought experiment has, a computer program has. And it's, if the AI is given faulty information, it's not going to come up with the right answer. AI has incredible, the speed and the amount of resources it has access to is incredible. But it's going to go in and it's going to assume that our existing physics paradigm is true. Because everybody says it's true, all the papers say it's true. And so it's going to be, it will repeat the same mistakes that we're making right now, I believe. And maybe there's something in some of the AI development that is beyond what I understand it to be. But it's not going to solve the problem unless there's a lot of discipline and separate fact and theory and then let it run with a lot of the things that we consider to be facts as variables. I'd love to see a list for the physicists go through a PhD textbook and identify what in that book is factual. If you have a book of particle physics, nothing is factual. It is blunt trauma research washed through a flawed lens and then delivering faulty conclusions. And it's too bad. It's the best they could do with what they have, but it's not good.
Had you heard of Abdul Salam, the man who unified fundamental forces?
There's probably a really brilliant guy who's trying to do something that doesn't need to be done because the assumptions he's using are incorrect. There is no strong force. There is no weak force. Gravity is not a force. All those things that require work and motion they have causes based on energy transactions. So fundamental forces don't exist.
Would you say that the problem with physics is a local problem or a global problem?
They're teaching the Russian students the same stuff that they're teaching our students, that they're teaching the Chinese students. It's a global problem. And they all get together. It's a relatively cohesive community. They share information. But they're all taught the same things in school. They're all dealing with theories that have been conflated into facts, and they're all hampered by the same thing. And that is an indoctrination into something that is false. Again, that has to stop. It is global.
Do you feel the world needs more people like Eric Weinstein?
I think the world has plenty of Eric Weinsteins. They don't necessarily have the platform that he has, but there are plenty of people out there that are questioning the status quo. Eric Weinstein goes so far, but he also was educated within the existing paradigm, and he's also affected by the conflation of fact, the theory of fact. So he's got limitations that lay people, outside people, do not have. It's a massive advantage for me not to have gone through physics indoctrination. I can think about things very differently than they can. they're limited in their range of thought. So, they'll come and say, oh man, you don't have a PhD in physics. You can't do all the mathematics. No, it's logic. It's not mathematics, it's logic. The math follows the logic. The observational mathematics is accurate, and it works through some convoluted ways with the existing paradigm, but it also works with the corrected model. It's the ability to think beyond their education. The only thing that's different between our corrected theory and the existing theory isn't the observations are right. The math measuring and quantifying the observations are right. The problem is what caused that to happen. The causes are different. We have causes for all of our stuff. They have mathematical plugs for a lot of their stuff. And we know from our observations with terrestrial physics for thousands of years that things don't just happen because they happen. Everything has a cause. And until they can get to the point where they can assign a cause to all the things that they see, the theory's wrong. It's just simple logic. It's common sense. They've made it so complicated that they can't even explain it themselves. I think it was Einstein that quoted, if you can't explain it to a 5-year-old, you probably don't understand it. I'm sure that's wrong, but it's something like that. That sentiment was right.
Creed, do you have mathematics to back up your theories and logic?
Yeah, it's exactly the same math that backs up their theories. The math is correct. The observational math is correct. The representation of it is correct. The difference between the corrected theory and the existing paradigm, the existing set of theories, is assigning a cause to each effect. What caused that to behave like that? What is the energy exchange that takes place when the apple fell on Newton's head? Why did it fall? We have an energy exchange on everything in the theory that scales from the atom to the galaxy. Math is good. It's just the applying cause and effect. They don't even try to give cause. It's a fundamental force. It doesn't need a cause. Gravity doesn't need a cause. Holding an atom together doesn't need a cause. The incredible magnetic fields that magnets create don't need a cause. They just happen. That's ridiculous. It's mind-boggling that they would accept that. That's so far from science, it's incredible. Where's the scientific method in making up a number and plugging it in and discovering stuff where there's actually no discovery? It's fraudulent. One of the big problems in physics and our incentives that we provide our physicists is in order to get your tenure and to get raises and to get promotions, you have to publish. Publish. Libraries full of garbage, but publish because they have to do it. Nobody ever reads it, but you publish it and you put it on your bio that you've written these papers and these books. So they can manipulate observations and discover things that don't actually exist and then write about it. And then everybody buys into it and the guy gets to publish a paper and he gets his tenure or they get their promotion. The subatomic world has got libraries full of stuff. Every atom is made up of 3 quarks. That's changed now, maybe hundreds of quarks. Well, have you seen a quark? No. Really, you break in all these things, you got no quarks? No, quarks can't exist on their own. Oh, okay. But they came out of the Big Bang, right? Oh, all the quarks came out of the Big Bang? Yeah. So they can exist long enough after the Big Bang to unite with each other somehow, and then they cannot exist independently. Yeah. It's mind-boggling what these guys can do on almost no scientific factual observation. Now, the research scientists are brilliant. What they've done with CERN is phenomenal, but it's all been directed by people with flawed theories. So they're searching for stuff that doesn't exist. They're not alone. In fact, I think all of the big money research right now, the look for dark matter, the search for cold nuclear fusion as an energy source, to the particle physics, all of it is wrong. And unless we have the discipline to go back and correct the core model, we're just going to continue to pour money down the rat hole.
When you say with discipline to correct the core model, is it discipline that's going to ignite a paradigm shift?
Self-sacrifice, though. The physicists have to say, okay, we've been misled. This isn't right. We need to go find answers. We need to change. And that is a hell of a sacrifice, because these guys have invested their entire lives in this paradigm. And if they go, man, oops, there go years of their lives. And also, you can't teach a class on astrophysics if you change the paradigm and the stuff that they're teaching is now wrong. How does a star mature? How does a supernova? What's the sequence of events that takes place there? It's all wrong. So now these guys need to study under the paradigm.
How does that paradigm shift? So does it happen in tandem? When there's a group that goes off and they make the shift while the other group continues down the wrong path, so that the disruption is not just, we have no basis?
I hope so. I hope that's how it happens. Well, I hope that there's enough curiosity to be looking at other alternatives. I don't know whether that will happen. That takes an enormous amount of effort and critical self-reflection. They've got to say, hey, there's a problem. But as I'm hoping it happens like that. But a paradigm shift is massively disruptive to the status quo. The status quo is very comfortable in the physics industry. So it's something that's it has received and will continue to receive massive resistance. What they want is to discover something that fixes all the problems. But the farther we go, the bigger the problems get, the more confusing the problems get. And at some point they go, oops, this isn't working real well. Whatever we're doing slightly wrong. It's like if you want to take an airplane from San Francisco to Hawaii and you put in north by northwest coordinates and you end up in Alaska. I mean, the farther you get away from San Francisco, the farther off course you are. And we are way off course. And until they recognize that and admit it and bite the bullet, it won't self-correct. It can't. And I wouldn't expect it to. It needs disruption. It needs Joe Rogan. It needs Elon Musk. It needs the big tech giants to say, bullshit. What you're feeding us is crap. Start over. Now, the technology revolution has been extremely successful, but that's separate from the physics stuff.
When you say separate, but it does potentially complement getting to the right place?
It could benefit from being the right place.
Okay.
It could benefit from being the right place. It's just, it's not benefiting from the existing efforts. Now, it's some incredible things have come out of it. The technology at CERN is phenomenal. And the internet came out of the physics industry. The nuclear power came out of the physics industry, but if you have fission. So lots of things, good things happen, almost by chance. But we're stuck. The God part, the purpose of the God particle was to try to describe why objects had mass, weight. Because Einstein's gravitational theory, large objects were attracted to each other. So they thought mass was an intrinsic feature of an object. It's not. Mass is measured in weight, kilograms. You don't have mass unless you have a energy exchange to create mass. Objects don't need to have mass as an intrinsic value. Objects have mass when an energy exchange takes place. You put your body in outer space, you are weightless, you're massless. You put your body down here and you have the waves of clear energy passing through you, you have mass, the energy exchange. And waves passing through you create mass. It is like everything else, it's the result of some type of transaction. in their model, it needs to be an intrinsic feature of matter. It's not. It's an action taking place to the matter and creates mass. So this to me is, I like this, and that's great. The Higgs boson does not exist. The Higgs boson is like a wino or a one of 200 different particles they discovered through their blunt trauma research. By the way, and none of these particles lasted longer than 10 to the minus 16 seconds. So I don't know how you define a particle, but in my mind, a particle has to have some stability. 10 to the minus 16 seconds, 16 zeros and a 1. That, if a whole particle is to a higher standard, it's got some stability. So all of the stuff you see that come out of particle physics and tried to be manipulated and answer questions, like a quark. Never seen a quark. They have 2 up quarks and 1 down quark. And the difference between a proton and neutron is they're just upside down. There's no up and down. They use a descriptor they call spin. Things don't spin. Then they have color. They have flavor. They have all these different descriptions, and each one of those things resulted in a bunch of papers that guys can write. And they're all buried in some library somewhere that some poor kid in college would be forced to go read someone's crap. So particle physics is problematic. And at some point you got to say, hey, we're not making much progress here. Then we're gonna recreate the Big Bang on our super colliders. We can go much faster. There's no Big Bang. You can't recreate something that hasn't happened. But the theory says it happened. Here we go. We're gonna have a hunt for the thing. I need another $10 billion. My super collider's not moving fast enough.
So is that what they're flying? Is that part of the goal of the research of what they're doing with these super colliders?
Yeah. To recreate the beginning of the universe. That's a goal. But you got to write something in your grant papers. There's got to be something that's worth $10 billion to the National Science Foundation. And that'd be worth $10 billion. Unfortunately, it didn't happen. So there, but it's part of the game. You got to do something interesting. Hey, we found 4 new particles last week. Well, how do you know they're particles? Well, we smashed some things together, and then our load of sensing equipment on the outside, which is tremendously complex and engineering a marvel, we found that the fragments that left the collision were of different weights than any fragments we've ever seen before, different energy levels. Weight, the size, and it's translated right back into energy. So different energy levels. So that must be a new particle. No, it's debris from a crash site that disappeared. It dissolved back into a state of energy that they don't yet account for. Oh, they ran into its antiparticle. Where'd the antiparticle come from? Well, it came from the Big Bang. It's just, if you go back and look at the Big Bang timeline, just take a look at it. It starts with 13.8 billion years ago. They had no idea how long ago it was. They have theories about it. They theorize up theory. Then it goes, in the first 10 to the minus 43rd seconds after the Big Bang, quarks were created. I came up with how it was. Something was created. And then the next 10 to the minus 35th seconds, all this other stuff was created. 10 to the minus 10 seconds, all this other stuff. First of all, you don't know how long ago it happened. Second of all, you have no idea. There's no scientific evidence whatsoever that any of this stuff in this incredibly complicated timeline ever took place. It's ridiculous. It is a bedtime story. And it's in every book. We talk about it as the beginning of the universe, and it's our explanation for why they think the universe is expanding. It's another one. The amount of information we have to support the idea that the universe is expanding that would require a Big Bang is insignificant. We sit on a little speck of dust in a moderate-sized galaxy on the edge of one of billions of galaxies. Our observational perspective is limited by that. We're passive observers of everything, with the exception of Moon, tiny bit, and Mars, tiny bit. We're passive observers of our own solar system, let alone something way out there. So, back in the 1930s, Edward Hubble just saw something he could be considered a redshift. A redshift, the analogy they use to explain it to people is like if there's a train and the whistle on the train goes up. Now, if the train moves away from you, the whistle sounds different. Okay. The wavelength is spread out. If the train is coming towards you, the whistle sounds different because the wavelength is compressed by the movement of the train. So they saw that. And this is tiny amounts of radiated energy have traveled billions of light years. A light year is 10 trillion kilometers. Multiply 10 trillion times a billion. That's how far it's traveled. A tiny amount of energy. And when it gets here, they see it, oh, that might be a redshift. Yeah, okay, well, what else causes a redshift? Well, the truck was between you and the train, it sounds like a redshift. If the wind blows, it sounds like a redshift. The same thing spreads out the wavelengths. This thing's been traveling a billion years through space. Who knows what that journey was? So the other option that Edward Hubble finally ended up grasping onto years later after his entire career was over is it's tired light. The radiated energy in my tired light, it's traveled so far, it's bent around other galaxies, it's gone through dust clouds and stuff. Its journey was affected. And so the universe is expanding. That's factual. No, they have a tiny amount of information and completely illogical application of that information. But there are other galaxies coming towards blue shifting. Well, for all came blue out of a big bang, shouldn't everything be moving apart? No. We're going to collide with the Andromeda galaxy pretty soon, in billions of years, but we're moving toward each other. It's just the expanding universe, which launched all this other stuff, which justified the Big Bang, all this other theoretical garbage, was accepted by the mainstream physicists because Einstein's gravitational theory, Einstein's theory of relativity, would have said that the universe had to be expanding or contracting, one of the two. It couldn't be stable. And when Einstein saw that there's a potential redshift, hey, the universe expanded. My math is right. No. So it's those wild goose chase. We're sitting on libraries full of... Anyway, there's so much of that. What's really interesting is you go back and look at where these theories came from. These massively important theories came from. There were things done in the 1930s. They were tiny scientific observations that exploded into this bizarre story about how our universe works. It's really interesting to go back and look at it. And if you do go back and look at it, which we did, it's like, you gotta be kidding me. That was a result of that observation in 1932. Electron orbitals is a really good one. The Bohr model of the atom suggests that the electrons are orbiting. It has morphed several times as we get better technology. We look at these things. The whole idea of orbitals is still in the description of what's happening with the atom, even though we know now in physics that it's not actually orbiting. They say it's jumping from point to point. We can't predict an orbit, blah, 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 blah. But the chemists are still using the orbital theory to explain molecular bonding, even though the physicists have decided the electrons don't orbit. It's like, come on, guys, something's wrong.
But they're both wrong.
Yes, for the same reason. But you'd think when you saw conflict like that, you'd be, oops, maybe we should rethink all this stuff. And there's so many of those where theories conflict with theories. And they're treated seriously. There's no self-reflection. There's no ability to adapt. Once it gets in there, it has to morph. It can't be removed. You can't remove a theory.
I was, we all were speaking with Wash a little bit yesterday, more after his interview with you. Was there anything in there in that conversation with Wash yesterday on Wash's view that stood out that you'd like to address a little bit more of?
I think I just hit 3 of them, or 4 of them. Yeah, there. I guess what really bothers me the most, and I think it's just because people don't give a shit, is why more people aren't flashing the red light. When more people are, because nobody looks into this stuff. Maybe got their lives are going down. The guys who are in it are so entrenched in it that they don't want to look into it. The guys that are on the outside look at me, and then that is so freaking confusing. I'm not going to waste my time looking into it. I wasted my time looking into it. You still looking into it? I am. I spent years getting educated in what's going on and going back and finding root cause of theories, and I did it with a physicist, and it took many, many years, and it's finally like, this is weird. It's amazing how such a tiny little bit of it. Mark Twain's got a great quote said, never in human history has, I can't remember, it basically says, has so much garbage been created from so little fact, so much theory. Mark Twain's the name? Mark Twain, it's beautiful. He says it much better than I could possibly say it. I haven't memorized it, but it's true. They have so little, and it's not their fault. We'll never go to another galaxy. We'll never get out of our solar system. We are passive observers of the universe. We cannot see the small stuff. We're restrained by our technological ability to see what an atom looks like. And so everything that we do down there is 99.99% theory, 1% observation. And the same with the macro. It's not our fault. We're doing the best we can with the theory, with what we can observe, limited by the theories that we've been handed down. And that's just crippled things. It's just poor theory.
You think AI is going to be crippled by the institution of card physics?
Yep. That's the only resource it's got. It's going to draw on that. And maybe they could figure out some way to get AI to question that and challenge them. I wouldn't think so. In my experience with AI, as you ask it a question, it does a massive job of researching all the available data quickly, and then formats it responds to you. But if the data it's accumulating is wrong, then the response is going to be wrong. I think we need to clean up the input before AI is going to help us advance in physics arena, at least in the theoretical physics arena.
So you're talking about the origins of the universe. In terms of the origins of the universe, the birth of the universe that we're in now, as a layman, I see it in an ascending order, like, the dimensions, in an ascending order, 1D, 2D, 3D, fourth dimension. And maybe that's why, as people, we see, there had to be the birth of the universe, this big bang. Because if our lives are finite, we die, stars die, people die, etc., there had to be the birth. But we're seeing it from this ascending order, from 1 to 4. But what if it's actually reversed, from like the top is the fourth dimension, and then we all kind of
dimension
with that.
Things we know about dimensions. We know they're sequential. We know each dimension is a subset of the next dimension. The second dimension is simply a whole boatload of lines, first dimension. The third dimension is a whole boatloads of planes, the second dimension. So we can project that the fourth dimension is going to be some superset of what we have here. We know that when you go from first dimension to second dimension to third dimension, it's laws of nature that are being relaxed. Things that are impossible to envision from one dimension or fall off the log symbol from the next dimension. You're in the first dimension. Hey, let's take a left. Physical impossibility. It's against the laws of nature. Go to the second dimension, go left, right, back, forth, whatever. Same with the third dimension. The fourth is going to be some jump similar to that. I'm just going to relax the laws of nature. And one of the laws of nature, when you talk about the Big Bang, the start and the stop, is in the fourth dimension, it is not restricted by linear time. There does not ever have to be a beginning or an end. And that's a really difficult thing intellectually to wrap your head around. And mine is not completely wrapped around it. But what we see is when we need to look at something and assign it an infinite designation, the infinite concept is the identification of a dimensional boundary. The other thing that's a problem with third and fourth dimensional people axis, if we do continue, our bodies don't go with us, right? We know the bodies don't go. What's left? It's a consciousness. In this dimension, all life that we know of is restricted to an organic structure. You have to have a body. From a blade of grass to a human has to have a body. So when we die, our consciousness has to be able to continue without a body. So those are the two biggies that on the next dimensional jump.
Like you're saying, like all these dimensions build upon each other, but could theoretically, because you're saying when we die, our consciousness has to live somewhere. You're saying your fourth dimension, could the fourth dimension have no physical space?
Yeah. There's no spatial limitations.
Right.
Everything we have that limits us is organic.
Let's say it was organic structures.
No, no physical mass in the fourth dimension.
It's not a construct. Yeah.
But it's an energetic place because energy never dies, right? Energy continues on.
The consciousness lives on top of the massless energy that we are reinserting as ether energy. If you think about massless energy, it's the fuel for all matter, and it is the foundation for consciousness. And that's how you begin integrating consciousness back in with the physical behavior of the universe. Now you have a platform that we can start dealing with it. There's a lot of debate about where all of your memories is stored and about where the creativity comes from, and the deja vu and all of that. And that can all be reintegrated back into the model that we have an on-ramp. Then clear energy is the on-ramp. Ether energy is the on-ramp. And the faster we get that in there, the faster we can actually start doing things that we actually care about, which is trying to understand why we're here, what is our purpose, and do we have a chance to continue on. And that they don't understand why nobody's interested in what they're doing. I do so many fun, exciting things here at CERN. Why does anybody care? It doesn't do anything for us. It does nothing. We started caring, thinking, well, hey, man, maybe nuclear fusion is going to give us some unlimited clean energy. Yawner alert. Nothing's happening. You starting to get consciousness and providing a platform that reiterates metaphysics, and you're going to have people's attention. Do something that's worthwhile. It's of interest. Darren, the rave.
Ray had some great rants in there, by the way. We didn't even have to incite you.
I ignore
You went off.
You give me a little booze, I can roll for hours. No.
Join the conversation at beyondeinstein.org